set and see nulls and quoted identifier on. But this is the structure of creating a database here. So create table, and then defined is a database object dot courses. And then you can see that each thing that's defined in the table when we create it is a column name, the type, data type that's allowed in that table, and then a few constraints here. So for course number, it just says we just want an integer. Null values are allowed. Yeah, this one indicates that it is an identity column. So for that referential integrity piece, this is the coding of it right here, indicating this is identity 1 of 1 in my database that I'm building out. Obviously, no null values allowed in that. Okay. So that's a little bit of how to create a table without anything in it, right? It's mostly very simple. This primary key cluster, we'll get to that when we start to look at some of the other things. So again, a lot of create table. Okay, and then down here, we've covered this already. So now that the tables have been created and defined up above, these are all just insert statements. So if we look at that, we covered that a couple weeks ago. That's pretty simple, defines the columns and then the values, and that's it. Yeah?
So I kind of wonder, like, just realistically in a real life scenario, I mean, are a lot of databases created from XLS or CSV files? Because this seems like it would be really cumbersome to do. Like, is it, like if you wanted to basically make a table from something which is already tabular data, but it's in values or something else, is that possible?
So yeah, no, that is possible. Where I think the difference is, this is probably less common, right? Than uploading it all through here. But this side up here, create the table, define the identity, null values allowed. This is quicker to do here. And then, yeah, insert a CSV file, and do it that way if you're uploading a lot of data. Yeah, that would make more sense. And then if this was an application, there'd probably really be a front end where every time they add a new instructor, there's, enter new instructor to the table, and the application takes care of that.
So yeah, and just like from pure experience, like the easiest way to do this is define your table identities, do that in SQL.
Yes.
And then if you have to upload massive amounts of data from whatever it is, a CSV or XLS, then there are ways that you can do that afterwards. But this is, if you want to identify table identities, this is the best way to do this.
Yeah. Table identities all written through here. Yeah, that's a good point, that this is not a very efficient way to write out and upload data to a table. Although, now I'm not as familiar with some of the functionality in here, but if let's just say I have it in here, script table as insert 2. So yeah, that built out some of it. It's not all I was. so I'm not as familiar with the Microsoft one, but a lot of these will have ways that you can just click on this and say, give me put it into an insert statement for me. And then it goes ahead and it puts each row into an insert statement. So that is a thing that happens as well. But yeah, either if you were building it from scratch and you said to the HR department, give me a list of all the job roles in the company, they'd give it to you in an Excel file. You might put it in a CSV and then take that, upload it to the table you've defined there. But yeah, that's a very good point. Okay. So where does that lead us? So we've I don't want to spend too much on this because this is really crossing into that database admin, and we don't have a lot of time for it, but let's do, I want to do a couple quick statements here. We'll say that we have an existing database and we're gonna just use AP as an example and create a new table with a constraint, okay? Okay. So create table, we'll pretend invoices has not been created yet, so call it invoices 1. Invoice ID, INT, so first you define the data type, then you define if it allows null values or not. Okay, so we'll do invoice total. We'll pretend we have everything in there. Data type is money, not null. And okay. And payment total money, not null. Okay. So right now this would be enough to create the table with the constraint, or with these things defined, data type, whether null values are allowed. Everybody good with that? No?
Yes.
Oh, okay. You shake your head like this when you mean yes, and it throws me every time.
Yes, it is.
Yeah. Okay. I'm gonna start to learn that. Okay. Obviously need a comma there. This needs to be 2 words. Okay. Now it would run with no trouble. Other things we can add here in the definition statement, constraints, I've talked about them. So let's say that we would like invoice total to be, questions?
So why money? Because invoice total is familiar with that.
Yeah, that's a good question. So it's more of an aesthetic thing than anything else. It'll show up in, if I just run a quick, thing here. It doesn't even, yeah. So this vendor ID is kind of giving us, that's what integer looks like. Money looks like this, and it defaults, I think it defaults to a rounded 2 decimal point by default. And that's more or less the benefits to it. But you're right, functionally it's not very different than just using a float or an integer. I think the biggest one you'll see is here, where credit total is defaulted to 0, but that's how it says $0, right? Yeah. Or this one, 40.2, but it keeps the 0 in. And it's not trimming that off, so it keeps that standard. So that's more aesthetic than it is functional. Okay, so we'll say though invoice total is, we do not want any invoices with less than 0. So we can add a constraint in by typing in check and then invoice total needs to be greater than or equal to 0. Okay, and that's how we might start to put some constraints in to say that, you know, if we try and enter something that is -7, we're going to get an error there. It's going to say that it's not a acceptable value in here, so please don't do that. So we can put them at the line level. We can also do this at this level here too, just to say that this constraint is part of the table. And one reason why you might want it at the bottom, maybe that constraint involves another column as well. Okay. And then just needs to move that bracket so the check is enclosed everything within the bracket. So we can put that constraint at the line level, or if it's got multiple things, keep it there. Make sense? Okay, so that's one form of constraint. Questions about that? Okay. So obviously the logic can get quite big on that one. Other thing we can do here is define our primary key. See how that lit up blue, indicating that we're using proper terms. So that is one thing there. And then the last one, of course, let's say we have the vendor ID in there, and we will say vendor ID is integer, not null. And you're waiting for it. We want the foreign key constraint. We want that in there. This one is still considered a constraint, but we type in references, vendors, so we specify the table, vendors, and vendor ID. And then we need to say Bell vendors correctly. Okay, so that would be how we define the foreign key constraint in here. Make sense? Okay. Okay, so now I have a new table called invoices1, not in Murat College, but in AP. Tables. Okay. There it is. It's empty, but I have key constraints. And yeah, I think you all believe me that I'm not able to put anything in here at $0, right? Yeah. I've earned your trust over the semester, and I will not test that one for the benefit of time, but I think the logic is sound there. We have done, okay, so that's clear. And then again, we have done drop tables. We've done that syntax before, so drop table invoice is 1. Actually, maybe gonna hold on to that one for a second. First one I'd like to do, bring all this back. Okay. Okay, so now we've got this table. As it often happens, requirements change and things need to be updated. So if we want to change the structure of a table, we use the alter table function. Alter table, invoice is 1, so we specify the table. And then there's a couple things we can add in. So let's say we would like to add a column. We just say add new call. We'll just call it new column. Say it's integer and no values are allowed. Okay. And then, hey, you guys probably can expect that that column is there. Fantastic. And then can do a lot of different stuff with this syntax. So I won't bore you with it, but we could potentially add a constraint. We can add or we can alter column, new column. It's actually supposed to be a date, right? Things like that, you get the idea. And then we can drop column, all the same. Oh, there we go. Okay, everybody's good with that? Okay, so that is essentially the database creation syntax. Create database, create table, define it, alter it, and drop.
What was the references?
The reference. Where was reference?
On the top of.
Oh, here. This was defining the foreign key. So this vendor ID is an integer that references the vendor ID column in, yeah. So actually that's a good one. That one, well, let's try and drop column. Where did I call it? Invoice. So try and drop that. And I get that this is not able to happen because it is a primary key. And we can see it built some sort of reference that that column is a primary key. Okay. Good. Everybody feel comfortable that they could build a database now? Yes, I do. I feel comfortable that you could all do it. Okay. So much so that I think it will be the final assignment will be a quick look at just creating and running some, really doesn't like that, eh? Okay. Well, it's not liking it there. Okay. So the last task assessment is, oh my gosh, this is not working. Okay, there we go. So a quick database design, adding a table. Adding a table to the My Guitar Shop website. And then implementing just a couple of scripts to build a couple of tables with some altering. This is this is going to be the easiest assignment you've done. Even easier than assignment task assessment 1. But we'll give you a chance to practice those and get assessed on them. And an easy grade at the end of the semester, which has got to feel good. So that is the last one. Okay, and I will make that do edit properties in place. We can do that. Okay, sound good? Okay. All right, so we are at 5:21. Now there's one thing that wasn't in the course outline and descriptions, but I would like to just quickly give you one more thing because I feel like I'd be wronging you if I didn't teach this last thing for SQL, and then you can go. And so it's not for marks. You can go anytime, but this is probably important to learn. Very simple though. The next week's class, I will be here, but I'm not bringing any more content. So it's more if there's questions about assessments or topics you want me to cover again, I will go over them. Otherwise, there's nothing planned lesson-wise for next week. So I will be here and ready to help and go for review, but nothing is planned. So just be in mind that, you know, it's possible that if you don't have anything you need from me and you show up, and nobody has anything they need from me and everybody shows up, there's not going to be anything to review. I can pick some random topics, but I will not have a plan for next week. Sound good? Okay. But this last one will take us about maybe 15 minutes, and then we'll call it for today. Sound good? All right. And this is maybe a good way to wrap up. Let's see here. I'm gonna use Murat College, and I'm going to build a script. Let's say select select star from courses, left join, I just need that as a reference, and I need to be in Murat College. Okay, this one you don't need to follow along with me. I will post it, but if you want to make your own query that you're like, this would be a useful thing to take for reporting later on, then that's kind of the idea here. So I'm going to go select star from courses, left join, student, courses, on, course ID equals B dot course ID left join. Actually, that's probably enough. That'll give me the count of students I need. Select A dot and I go. Course number, course description, and I'm going to go count. Okay. Group by. Okay, so let's say I have this script that I run, and it gives me a count of students in each class. That's what I've done here, right? I've joined, I have the course number, course name, number of students in each class. Okay. Everybody's like, where's the Teams so we can paste it? Did not open Teams. Okay, so that's what this is. Very unremarkable. Amateur hours to you guys because you're so good at this now. But okay, the idea here is we've gone over how to copy and save and call a file, but that can be a little cumbersome because in this line of work we like shortcuts. So if I want a quick look at this, you could build it into a table, but then you'd have to rebuild that table every time you wanted to call it, right? Like if I said create table like this, then every time I wanted, if there was changes, I'd have to drop the table and recreate the table. Not ideal, because assume the data is static, right? People drop courses all the time. People pick up courses less. Some of you are thinking you should have dropped this course a while back. But it's done now, so no big deal. The point is there is something in SQL called a view that kind of saves a query, and it's able to pull data quickly from, and it just essentially runs those queries.
Is it like defining functions in Python?
No. It's different. There are actually functions in here as well. Okay. So it looks like this. It's create view as. And then I need to name my view as well. So I'll call it VW student count. Boom.
Spelling for view.
Oh my gosh. Thank you. Wait, did I have the, no? There we go. Okay, so I've run that. We saw what the query looks like. Commands completed successfully. Yay. Okay, and now when I go here, I see my object student view. So the cool thing is now I have that query saved in here. And I can just pull it, view underscore student count. And then my view is just pulled up like that. Okay, that's kind of cool, right? It's very useful because as the underlying data changes, as I said, this view updates and it's easier to pull through. The next thing that makes it good, if I'm running reporting then in Tableau or anything else, it's easier to pull from here using that underlying view that's defined in here. Oh no. I'm not. We can connect to SQL Server. This is the same login when you boot up SQL, right? You've seen this every time you log in and your Windows credentials come up. So now it's connected to there. All my databases are here. That's kind of as expected, right? So where did I build that? I actually built that in Marac College. So it gives you the option of all your base tables here, but the view I created is here as well. So for the purpose of this connection, I can just pull that view in here, and it's already defined in SQL and makes it easier to kind of manage that script, and you can pull from there as needed. And then, you know, build your visualizations off it as needed. This was very simplistic, but more just wanted to show the, I mean, you know how to do this. This is nothing revolutionary in Tableau. The big thing here is just the ease of connection. I have my named object that I know is that thing. I did not have to create a new table that had that, and it's dynamic based on the underlying data. Make sense? So views, very useful. A couple things about views. This object does not store any data. It just runs the query when you ask for it. So it is not holding data. That's why I'm saying it changes as the underlying data changes. When you call it, it runs the query and gives you the result set based on that. You can obviously you don't need to run the whole thing. You obviously can do the same, treat it like a table, right? Just call one column at a time. If you need to run some sort of group by function, all of that, you can do that on a view.
Would it degrade the performance? Like, firstly, it will create the view, and after that, it is fetching the particular column.
Yeah, it's like yeah. So it's not as, if you run a group by on it, it's not going to be as efficient as running a group by on a table that's stored in system, because then it runs the query and then it runs the group by on that. So there is an extra step in there, but it does, work the same way, right?
Can we see the query or we cannot see the query which we wrote, which we written earlier?
Yeah, so let's see here. This is script view as, where is it? Columns. Let's try this one. So that would create so it pulls out the script here, right? It just gives you all the proper syntax here. Create view, database object, this is essentially the same thing. But there's my query in here that I ran. So that is stored in here. If I change something on the view, this is one that I'm not as if I change something on the view, say we don't want course number in there for whatever reason, could be any change, and I run that, it says there's already an object named that, so I do need to drop view and then replace view. And then rerun that. So that's how you change it. Still easier than building a table every time, and yeah, very, very common in analytics when you have a reporting view that you need to see. It gives you that. It doesn't duplicate the data, which is good, and it saves your query. So if I was running this from a database management perspective, I would have this script saved out of SQL Server somewhere, and I would, when I update it, I'd import my script, make the change, pull it out. You have it here as well, but just keep it out of system in case something happens where you need to put it back in and put everything back together. Anyway, those are views. Any questions?
So basically, if you want to update the view, basically we have to drop the first one, the first query, then we can only update.
Yeah, I think so. I 100% modify views. Oh, you can do alter view. So that would make sense. Okay, so alter view would be the new script to do it. That would be the better way. Yeah. That's one point where it's different in the Oracle one that I use every day. Oracle, it's create a replace view and you run that, but this is different. Anyway. Same idea. So again, you cannot use things like update and insert on a view, right? Because it's pulling from an underlying table. So if you want to insert, then you need to insert to the,
Query.
yeah, insert to the base table. Yeah. Okay. All right. Well, that's it on views. Covered a lot today. It was a lot of fun. But yeah, that's it for the contents of the course. So again, next week is review only. If nobody brings anything, I don't know if I'll have much to go over. We can pick some topics. Otherwise, take the time, work on assignments. I will be here,
The
but
next semester will continue on this, or it will be something different, like,
what's that?
this will be a part of the next